This quiz is on hydrocarbons. Knowing that, I pulled in table P, which tells me my prefixes based on the number of carbons, and also table Q, which shows me my three different homologous series, the alkanes, alkenes, and alkynes, based on whether or not they have all single bonds, at least one double or one triple bond. So the first thing I like to do when I look at a hydrocarbon is notice anything significant. This should actually be an H. It just didn't pull in well when I made the PDF. So these are actually just a series of carbons that are single bonded. So I'm going to start by counting my carbons. 1, 2, 3, 4, 5. And when I look in table P, I see that 5 carbons means I'm going to use the prefix pent. So I'm going to go ahead and put pent down. And then I already noted that all of the bonds between my carbons are single bonds. So the homologous series that includes all single bonds is the alkanes. So the ending on that name is going to be ANE. So that is simply pentane. The next one, as I look at my hydrocarbon, I do have something significant here, so I'm just going to circle that. I have a double bond, so that's going to be significant. Now I'm going to go ahead and count. 1, 2, 3, 4 carbons. 4 carbons means that I need a but in the name, and that's just going to be B-U-T. And then because of that noted double bond, when I look at my homologous series, it's not going to be the alkanes that have all single bonds, but the alkenes. And all you do is add ENE to the ending. And then because there are options as to where that double bond could be, it could have been between the first and the second, or the second and the third, I have to give that double bond an address. We're going to count from either end of the chain just to make sure that we're using the lowest number possible. If I start from the left, this is carbon 1, this is carbon 2, so it would be on the second carbon. Starting from the right, this would be carbon 1, this is carbon 2, so again it'd be on the second carbon. So we're just going to say 2-butene. Next one, again, I have something significant here. I have a triple bond. So after I figure out my prefix, which there are 3 carbons, so I'm going to use prop. I'm going to need to look at my homologous series, and the one with the triple bond gets a YNE ending because they're alkynes. So I'm going to put YNE. And this one actually, it won't matter if you use the address or not, because it's always going to be on the first carbon. The only other option for where this could be would be here, and then we would call this the first carbon. Because remember, these are three-dimensional. We could be looking at them from above the paper or below the paper. So they're actually the same thing. So I'm just going to put a 1, but if you left it off, that's the only option. It wouldn't have been wrong. It would have had to have been on the first carbon. All right, next one's kind of tricky. I have a branch, obviously. The question is, where is that branch? When you name the chain, it has to be the longest chain possible. So if I just went horizontal, that would be 3 carbons long. But look what happens if I were to make a right turn and go down here. I would actually have a 4 carbon chain. So let me start from the other side, 4 carbon chain. So you got to check every possibility, starting with a terminal carbon, to find your longest chain. So my longest chain is actually 4 carbons long, making this my branch. So I'm going to go ahead, 4 carbons, looking at table P is but. They all are single bonded, which will give me an ane ending. And then I need to indicate that I have this branch here, and that branch is 1 carbon long, meaning meth. So that goes out front. Should have left myself more room. And then you just add YL to indicate that it's a branch. And then you should say which carbon that is off of Turns out that's the only carbon it could be off, but let's go ahead and count. This is carbon 1, 2, so it's off the second carbon. Or if you count it from this direction, 1, 2, 3, we always use the one with the lower number. So we're going to count from this end, and that will mean it's off of the second carbon. So we would say 2-methyl butane. And the point I was making about it would have to be off the second carbon. If this branch were off of this carbon, then we would have just counted from this end, and it still would have been off the second carbon. All right, next one. Again, my H's are just kind of being dropped off for some reason when it converted to a PDF. Next one, we have a 3-carbon chain. 1, 2, 3 means prop. So I'm going to go ahead and write prop. They all are single bonded, just like this example. Ending is ANE because it's an alkane. Next one, I have some significant things to note. There's a triple bond and a triple bond. Now I'm going to go ahead and count 1, 2, 3, 4, 5 carbons. 5 is pent. And then we got to be really careful. We have 2 triple bonds, so this is kind of tricky. When you have triple bonds, you're going to say YNE. But when you have multiple of these triple bonds, we always put a di in front of that ending. So we're actually going to say pentadiene to say that there are 2 of those triple bonds. And then you also need to say where they are, because they could be on 2 carbons that are right next to each other. If this one weren't here, it could be here, or this one could be there, or this one could be there. So you got to say where they are. So if I counted from this side, they would be on the 2nd carbon, 3 and 4th carbon. Or if I count from this end, it's on the 1st, 2nd, and 3rd, 1st and 3rd. So we're going to count from this side. And this becomes 1, 3 pentadiene. I know there's a lot in there. All right, on to number 7. I'm going to note that I have these extra branches off of here. My longest chain is here. Even if you hadn't used the horizontal, if you'd done it this way, there still would have been a 1-carbon branch off of that 2nd carbon. So it kind of would be easier to do it horizontal in this case. My longest chain is 1, 2, 3, 4, 5 carbons long. This time and 5 carbons is pent. They are all single bonded, so that's ane. And I once again forgot to leave myself a little space for those branches that we have off our main chain. So here's the thing that students tend to mix up when it comes to this. This is a 1-carbon branch and this is a 1-carbon branch. And students like to try to link them together and call it a 2-carbon branch. But if in order to connect those two, you have to cross your main chain, they are separate branches. So they are each 1-carbon branches. So we have a meth or 1-carbon and then YL branch, and I have 2 of them. So you have a choice. You can either say dimethyl or you can say methyl-methyl. I like to say dimethyl just because I'm a little lazier. And then of course we have to say where they are. So we're going to count our carbons. If I count from this side, it's 1, 2. They're both off the 2nd carbon, where from this side it would both be off the 4th. So we're going to use the 2nd. And you do actually need to have 2 addresses, 2,2-dimethyl pentane. On to number 8. Looking at this one, I have a triple bond. So I know that's going to be significant in naming it. I'm going to count my carbons, 1, 2, 3, 4, 5, 6 of them. So this time it means we're going to use hex. But instead of an ANE like we often use, because of that triple bond, I'm going to use a YNE. And then I need to give the address of that triple bond. So I'm going to count from the left first, 1, 2, 3 on the 3rd carbon, or from the right, 1, 2, 3, same thing. So we're going to call that 3-hexyne. Next one, nothing terribly significant here. We'll just count our carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is known. N-O-N. They're all single bonded, like our example here, which ends in A-N-E, nonane. And that's it. Don't have to give an address of anything since there's nothing significant. Next one, however, we have a double bond right here. So that'll end up being significant. For the time being, though, let's count our carbons. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons is oct. And then we have a double bond. A double bond means it's going to end in E-N-E. And then we need to give its address, and it needs to be the lowest numbered carbon. So we're going to start from the left. 1, 2, 3, 4, 5, or 1, 2, 3. It's actually going to be 3-octene. Now we're going to go from the name to the actual structural formula, and I actually prefer this. I feel like I'm not going to forget to do something that I need to, since all of the pieces that I need are right in this name. I like to start with my main chain, my longest chain first, and it is hex long. Hex, looking at table P, is 6, so I'm going to have 6 carbons. 1, 2, 3, 4, 5, 6. They are bonded by ane, ane meaning that I have an alkane or single bonds between my carbons. That should be a single bond. Let's see if I can figure that out. Yep. And then on my second carbon, I have a meth or 1 carbon YL branch. Doesn't matter if you go up or down off that second carbon. I'm going to go down just because it feels like there's more room. Now we're going to add in hydrogens to make sure that every carbon has a total of 4 bonds. And we don't have to draw in the H's anymore. You're practically chemists now. And we're done. Just double check you have 4 bonds on every one. 1, 2, 3, 4, 1, 2, 3, 4. And that's all I do when I check your paper too, is kind of swirl my pen around each carbon. All right, next one we have pent or 5 carbons. So I'm going to start there. Okay, and there are di or 2 ene or double bonds. So I have 2 double bonds, and they are on the first and the third carbons. So on the first carbon and the third carbon, all the rest are single bonds. This is where you need to be super careful that you only have 4 bonds on each carbon, because this carbon already has 2. I'm only going to add 2 more. This carbon already has 3, so 1 there. Doesn't matter if you go up or down. I know this is nonpolar, so I'm trying to make it symmetrical. Number 13 looks a little scary, a lot going on there, but if you just take it one thing at a time, I'm going to look at my main chain, my longest chain first. It is oct long, which is telling me I have 8 carbons. Got to make room for that. They are all single bonded since it's an alkane, so single bonds. Oh, it's only going to have a hydrogen on it. And on the 4th carbon, there is a 1 carbon, meth means 1 carbon branch. So I guess I'll just decide to count from this side. So on my 4th carbon, I am going to put a 1 carbon branch, and on my 3rd carbon I have an eth or 2 carbon branch. If I can get that to draw. And then I just need to make sure all my carbons have 4 bonds. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. Don't want to lose points for that. And we're done. Next one, we have prop, or 3 carbons. And then the ene is telling us that we have a double bond. They didn't tell us where to put it, and actually it doesn't matter, because with propene it's always going to be on the first carbon, even if you drew it in the other space, because then if you had drawn it over here, this would have become the first carbon. Now making sure all the carbons have a total of 4 bonds, and we're done. Next one, we have bute, or 4 carbons. And they are ane, or single bonded. Off of the second carbon, there's a 1 carbon branch, and also off the second carbon, there is a 1 carbon branch. So you could have said 2-methyl, 2-methyl, or 2,2-dimethyl. Both mean the same thing. So off the second carbon, I'm going to have a 1 carbon branch. What's really important is that the other carbon needs to go off the other side of that main chain, because if you connect it to this one, it's no longer a 1 carbon branch. And then make sure they all have a total of 4 bonds. And we're done with that. Pent, or 5. Ane tells me they are single bonded. There are 2 1 carbon branches, 1 off the second and 1 off the third carbon. Doesn't matter if you go up or down. If you happen to put them both going the same way, both up or both down, just make sure that they're not bonded to each other. Sometimes students draw it so they're kind of sharing a bond, and they can't be. The angles don't work out. Hept, which means 7. And ane is telling us that they are single bonded. And then a total of 4 bonds on each. Remember, these bonds are actually bonded to a hydrogen that we're not bothering to draw. Dec, or 10 carbons. Ooh, should have made it a little smaller. And off of the 4th carbon is where we have that YNE, or our triple bond. 1, 2, 3, 4. And then single bonds everywhere else. And then just be careful, these 2 carbons actually already have 4 bonds. So when you go to add in the rest of your bonds, don't give them any. They're all done. And that one is now done. We have oct, that is 8. And there is a double bond on the first carbon. All the rest are single. And then make sure they all have a total of 4 bonds. This one already has 3, so only 1 more. This one already has 2, so 2 more. Last question is asking for an isomer of pentane. If you want to draw pentane, you can, but that's not going to count. You can draw it as a way of helping you figure out one of the isomers. The easiest thing to do is to pluck off one of the terminal carbons and stick it on an internal carbon. So pentane is 5 carbons long. I'm going to draw it only 4 carbons long. That 5th carbon is going to be plucked off the end, and I'm going to stick it on one of my internal carbons. These are terminal. If you put them on those carbons, it's just going to make it a 5 carbon chain again. So you need to make sure you put it on an internal carbon. Give them all their total of 4 bonds. And the other part of this is, of course, to name it. So my longest chain is 4 carbons long. They are single bonded. And then I have that one carbon branch, and it is on the second carbon. And actually, if you've left off the address, that's still right, because if you'd put it on this carbon, it would still be the second carbon because we'd start from the right to count. So the only way you can have a methyl branch on a butane is to have it on the second carbon. And that's what the quiz is going to be like. So good luck.